Okay, so just like we can convert a linear system into a augmented matrix, we can go vice versa, right? So for example, let's say we are given the augmented matrix. Okay, and then we want to change it to a linear system, right? So again, if I know that this is an augmented matrix, then I know already that the columns represent the coefficients for my x, y. In this case, what this augmented matrix is already telling me is I have a linear system in two variables and two equations, right? Where this is going to be my constant. Okay, so going from this to the linear equation system, right, we would have 3x plus 4y equals to 10. And then the second part of my equation would be 10x plus 17y is equal to 43. Right, and that would be the linear system representation of this augmented matrix. Right, and again, we can take the same approach to a matrix of any size, right? So let's say, for example, I have a 3 by 4. We have 4, 5, -2, 12, 0, 1, 58, 2, 8, 7, -3, and -5. All right, so let's say that this was my augmented matrix, right? So right away, what I know here is that I have 3 variables and 3 equations, right? X, Y, Z. Again, that's just standard kind of practice, right? Sometimes certain books, you'll refer to them as X1, X2, X3, the variables, but again, the variables, we can call them what we choose to. Right, here in this course, we choose the standard, just X, Y, Z formulation. And again, equal to, this represents our constant. Okay, so the first equation, we look at, these are going to represent the coefficients. So it's 4x plus 5y minus 2z is equal to 12. All right, looking at the second equation, now there's a 0 there. So what that's telling me, there's been no x part for my equation, so we can just start with the y. No need to write 0x, we can just leave it off. And plus 58z is equal to 2. And now the last equation, the coefficients 8x plus 7y minus 3z is equal to -5. Okay, and that is how I go from an augmented matrix into a linear system, right? So now we done a system to augmented matrix, and now we have augmented matrix to a system. So we should be able to go between the two styles depending on what we're looking for, right, or what we need rather quickly.